Okay, so some of you maybe know how to do this, but when you're giving multiple numbers, it only just compounds to the complexity of this, if you want to call it that, because the problems that we worked on last week, okay, it told you how much of the anhydride that you had and how much water was driven off. Well, we can't do that in the lab. We can't speculate how much water you're going to drive off, how much hydrate you're starting with, and how much hydride will be left over. So we want to try to get on the same page to increase our best possible chances that you get this right. And whether it comes out to a whole number of 2, 3, 4, some of the hydrates we have, I looked, I've seen 2, I've seen 3, I've seen 5, I've seen 7, and I've seen 9. Okay? So we don't want, oh, how do I do this now? How do I do this now? How do I do this now? We're not going to hear that tomorrow, correct? So if you can't make that promise, what might, I'm just speculating here, what might be the best chances of increasing your ability to write this down? And I've said this in other classes. Is it 1, we already know how to do this? 2, we really don't care? 3, we're too lazy? And maybe you already know how to do this. And if you do, great, then it makes it our job that much easier. Because we're going to be using terms like, of course, you see this. Okay. And I don't know, we've had that discussion in other classes that they stipulate, yes, there's a glare. We all understand that. So if that is the case, you need to be able to move. You can move closer. You have to move around, try to get a better opportunity of reading this. And said, well, they survived. People who have graduated in years past, and you can and or will too. Okay? So to help you out, what it says, we're just presuming that, you know, this is perhaps something you may have to do in your college lab. Okay? A student, or maybe students, maybe you're working by yourself, must determine the amount of water tied into, in this case, it's magnesium sulfate. Okay? So at the lab station, when you weigh the crucible, that's how much you may get. Okay? 22.82 grams. Then is, of course, you would say, no, that is not your hydrate because you haven't added anything yet. Okay? So that's my point, is you don't know how much of a hydrate that you're going to have. Just like when you fill your semi-trucks or your gravity wagons full of corn and or beans, you have no idea how many bushels are in there. Okay? So it's the same concept. Okay? So then after adding the hydrate, okay, the mass is 36.34 grams. Then after heating the hydrate, okay, I don't know why I have there. I might have got interrupted. After heating the hydrate, the mass is 6.60 grams. What is the formula of the hydrate? Okay? And if I was perhaps sitting on your side, I'd say I have no idea where to start after maybe about 4 steps. Okay? So step 1, okay, first of all, what is magnesium sulfate? Okay, so then when I say X, that means Is there 2 moles of water, 1 mole of water, 3 moles of water attached into that hydrate? Because when we say, okay, that's hydration. Of course, that's hydration because you are hydrating. When you do that, what are you adding into your body? H2O, you're adding water. So in this case, when we're talking about a hydrate, we're talking about this compound that's tied up with how many moles of water? We don't know. 2, 3, 4, 5, 7, 9. Could be any one of those. Okay? So then, if the hydrate is this with however many moles of water, what is the anhydride, do you think? Okay, I'm just asking, what do you think? Okay, hydration is adding water, so then anhydride must be just the opposite. So it would be what's left over after you've driven the water off. So what we mean by this, okay, after heating the hydrate, you're driving that water off, okay? You're heating it up and it just evaporates into the air, okay? Just magically disappears, okay? So what we can presume is we need to know how much of that hydrate did we start with? And it doesn't tell you up here, okay? It's just like, how do you figure out how many bushels are in your truck or your wagon or whatever? Yeah, you're going to be there for a long time. So I like to say either you weigh heavy or weigh full and then weigh empty again. And then subtracting the two gives you what? Your weight. Yeah, your your net weight. Because when you weigh full, that is your gross weight. Then when you weigh empty, that is your net weight. Same concept. So in this case, okay, this is your crucible, okay, when it is empty. So if this is what it changed to after weighing your crucible, what can we presume from that? You're going to subtract these two. So that means 36.34 minus 22.82, okay? 13.52. Now, okay, is that this, or this, do you think? This is the mass of your hydrate? Okay, you also have to take into account, have we done anything to this yet? No, so it can't be your anhydride, okay? So it can't be this, and it can't be that, okay? This is the mass of your hydrate, okay? Because all you're doing is you weighed your crucible. Of course, this would be a really big crucible. And then however much you add in there, because not everyone's going to add the same amount in there. Some of you might put in 5.8 grams. Some of you might put in 10 grams. But you also have to take into account the more that you put in there, the longer it's going to take for you to do this process. So my suggestion would be is to try to keep it under 10 grams. So if it's 12, fine. If it's 8.5, great. And if it's 6.7, that's fine too. Okay? My point is not everyone's going to have the same hydrate, and chances are you're not going to start with the same amount. Because again, some of you might have iron chloride with a certain number of moles of water. Some of you might have iron nitrate. Some of you might have manganese nitrate or cobalt nitrate. All those compounds have water locked into each one of them, which gives you a hydrate. Okay? So this is our hydrate. So then once we do this, what did it say? In this process, we heated it up, and then what happened? Okay, so that's going to evaporate out of the air. So then what that would presume, okay, we've heated it up. What did we drive off into the atmosphere? You drove the water off or driven it off? Drove? Oh, okay. Well, let's try to keep this as simple as possible. Sure. Okay. So then this is your anhydride then, okay? So we heated it up. All that water got sent, was it? Okay, sent, whatever. Okay? So this is our, I'm going to write anhydride, because that's the white powder that you're going to see left behind. So we have that right here, 6.60. This one was 13.52. So then how much water did we drive off of this? You got to subtract those two. And upon doing that, what do we get? 6.92. Okay? Of course, this is grams, okay? This is your magnesium sulfate times question mark. This is just your magnesium sulfate, and then this is what? Okay, now you're into familiar territory. Okay? So we hope that you extrapolate, or you're getting numbers that actually mean something over in the lab. Now, when you get these mole ratios, the chances of it hitting a 2, 3, 4, 5, 6, right on 6.0, I would say it's probably minimal. It's not that you're bad chemists. Maybe it's a bad teacher. I don't know. Or maybe it's bad lab procedure. I don't know. Take your pick, okay? Because I just know we're just riddled with anticipation that, yay, fire! Get to play with fire tomorrow. Okay? So, now the reason I say that is once we got this into familiar territory, now you can use your logical skills of molecular or empirical formulas, do you think? Empirical formula, because we're not really associating to make sure if this is the right formula. So now, what that tells you, you take this many grams and you convert this to what? Moles. You take this many grams and convert it to, and then once you've done that, what's your final step? Divide by the smallest number. Okay? So once we do that, let's go ahead and try to move forward with this. 6.90 grams of magnesium sulfate. Oh, 6.60. We were just seeing if you were paying attention. Yeah. Okay. So how do we get rid of this gram then? Magnesium sulfate, grams of magnesium sulfate. So 24.31. And I've asked you this before. How many of you have the periodic table, a lot of it memorized? Not because you are forced to, but because you've used these numbers so many times. And you get maybe approximately 120. Okay, 120 point, I got 0.37, but okay. 120. I'm going to do, okay, 3.8, okay? Then we can presume the same thing that we would have to do for our water, 6.92. Gonna divide that by 18. So then once you do that, we get, okay, 6.92 divided by 18.02, get 0.384. Okay. Oh shoot, I did this one. I'm sorry, what do you get when you divide those two? I'm getting a little ahead of ourselves. 0.054 and 8? Okay. 548. Okay. So now that you've got it down to this step, okay, how many moles of magnesium sulfate are there? No, according to our empirical formula. No. We're going to divide this number by what? The smallest one, which gives you what? I can do that math. I got that right. I'm going to say 1. Okay? Then what happens when you divide that by the smallest one, which is 0.0548? Does it perfectly 7 or 0.007? Okay. 0.384 divided by 0.0548. See, I could have swore he said 0.007. That's why I had a disgruntled look on my face. Okay, so then that approximately gives you 7. Okay, so what can you conclude from this? How much of that is water? 7 moles of water are attached to every mole of magnesium sulfate.
Is that 18.02, Mr. McKinney?
It is. So the last thing that you would do is we know we've got 1 mole of magnesium sulfate, and then the question mark gets changed to what? 7. 7 moles of H2O. Okay? All right. So hopefully this works off. What's going to make the biggest difference is when you go through this process, okay, you had that much of your anhydride. Excuse me, your hydrate. So when you drive that water off, you have to keep going until this number doesn't change anymore. Okay? Because in this case, maybe you come up with, I don't know, 8.10. Okay? Then maybe you let it heat for a little longer. Now it's not 8.10, it's 7.48. What does that tell you? You're still burning some water off. So what you have to do is, there's really no set number or increment in here. You will say 5 minutes. You have it in a crucible, and then you weigh it. And then, okay, so that gives us this amount. We're going to put it back on the burner and let it burn for another 5 minutes. If that number hasn't changed, well, then you've driven all the water off. But if it has, that tells you still have a little further to go yet. That's maybe a little difficult to perceive or figure out or understand. Does that make sense? Because we're trying to explain it in the best possible manner that we can. So when I'm looking at this, let's see here, 2, 4, 6, 8, 10, 12, 14, 16, 18. So we're all here. So I would just presume that each one of them is your lab table, and then you two. Okay? Make sense? None of it makes any sense. We just make this up as we go.
That's what I've been hearing.
That's why you're here? Okay. Yeah. If you don't know what you're doing, just make it up, right? It's gotten you this far in life, huh? How much further in life is that going to take you?
I'm willing to find out.
I wouldn't try to go down that road. It might not end well. Or it might end all right, but there might be a few too many bumps on the road. Okay. We can just go ahead and pause this for a moment. Just saying, I wished I didn't erase all that. We had, it was 6.9, was that our anhydride? 6.92.
No, our anhydrite was 6.6.
Okay, so we know that this is 6.60 grams, okay? What's the percentage of oxygen? Disregard the water portion, okay? So the reason I say that is a really higher advanced problem that you may encounter in college is if you have to do this, you may have to take that oxygen and content as well. That's why we're just doing the anhydride. We drove all the water off. Of those 6.60 grams, what's the percentage of oxygen in there? That is what we will be doing on Wednesday. At least that's the plan. So also before I forget, when Thursday rolls around, okay? 1, 2, 3, and I don't think I missed anybody. Depart school. Okay? So you're still here for your favorite class. Okay? At least it's not in the morning where you miss A and P, right? Oh, that's right. You 3 aren't in A and P anyway. So, all right. See, it's just riddled with, I can just see the dopamine flaring in your minds now. What's dopamine? It's not dope like, well, that might be you guys, but what's dopamine? No. It's what? No. No, I don't think so.
The people in A and P don't even know.
It can give you energy.
We learned this last year or sometime.
No. Well, yeah, that would be close since we're talking about the brain. Yeah. Okay, well, yeah, dopamine is a chemical. Okay. Yeah, well, is it the corpus striatum, I think? Yeah, the corpus striatum. It's why did the young lady jump off the cliff? She was running from her chemistry problems? No, yeah, that could be, but why did she jump off the cliff? Yeah, because the corpus striatum in the brain is saying, you are going to enjoy this so much if you jump off that cliff.
You will be 6 feet under. You'll enjoy it.
Well, she's got a parachute. So, yeah. Okay. All right. So, I just know your dopamine is flaring off, that we just are riddled with anticipation and happiness. That's what dopamine gives you, that when we continue with this. Does someone have an answer for that?
Oh, it's 51%.
51%? Is that accurate?
How the heck did you do that, or did you just?
I did it in my calculator earlier. I remember a simple number.
Maybe that's right. I don't know.
It's 13.52 divided by 6.92. So.
Oh.
No.
I don't think so. 6.60 grams, okay? That's magnesium sulfate. That's why I said I wished we hadn't erased that. Was it 120? Is that the mass of your 120.38, okay? Grams of magnesium sulfate. That gives you a mole of magnesium sulfate. Therefore, we can conclude, okay, this next step is so important. Why?
Because when we get farther down the road, it's.
You might be right too, but that's more accurate over here.
There's 4 oxygen.
True, because since there's 4 oxygens, we can do this. We can make this presumption that for every 4 moles of oxygen, we're still dealing with 1 mole of magnesium sulfate. Okay? Then, our final step is, now that all of these have canceled, now what substance are we dealing with? Now we're dealing with oxygen. So for every mole of oxygen, we get 16 grams of oxygen. Now, some of the things I think that happens when we get further down the road is, once we get past this chapter, we don't deal with this anymore. It's that. If it's just oxygen only, but if it's by itself. But that's more so reaction stoichiometry. This is still composition stoichiometry. Okay, so now, once we take 64 times 6.6, we get, okay, so 6.6 times 64, we get 422.40. Okay, but then we still have to divide that by 120.38. 3.5088. That doesn't look like a percentage to me. You're shaking your head no, because there's one last step. What is it? By? No. 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 No.
I forgot how to do this. What's the question?
You literally move it left wing.
No,
No.
because it would have given you like a decimal.
Don't move it.
Why don't you? Can you just do 120 divided by 120? You can't do it like that.
So this is how much oxygen we have, but it doesn't say the percentage of it though.
Divided by
Divided by 6.6.
Right. Okay, now, could we conclude that if we took 100 grams or 100% and took 53 off of that and we get 47, could we conclude that this is what, 23.50 and this is 23.50?
no, because they're massive.
Because their masses are different. That's right. It might be pretty close, since this is a little heavier. Maybe this is somewhere around 28, and that's maybe around 18. Right, because the masses are different. Okay. Haven't asked yet. Back left row, are we on the bus?
What would your answer be there?
Back left middle. Is that a yes? Okay. Middle right outside. Okay.
Middle right outside.
Okay. So, middle left inside. Okay. So back right middle inside. Okay. So middle left outside. Okay. So front left middle. Front left right middle. Front right outside. Okay, so middle right inside.
North, south, outside.
I think that's everybody. So I didn't do back right outside. Okay. Okay, so hopefully this works out. Sometimes it's just a crapshoot. Sometimes it works. Sometimes it doesn't. Now you got to remember, this is in a lab. It's not always going to be 100% accurate. Now whether you're going to come out to a whole number like this, we'll keep our fingers crossed. All right, we'll catch up to you next time. Oh, maybe I should have stated, do you need more practice with how to do these problems? Molar mass, that is this. This is molar mass problems. This is percent composition.
Wait, so
They're the same thing. It's just percent composition has that one extra added step.
Did you give us our worksheets back from that one that we did, percent composition?
Yeah.
I'm pretty sure you graded them.
I'm pretty sure I graded them, but I don't know if I handed them back. I see one in here. My guess is yes, because I only see one. At least I believe it has been graded. I don't know. I've got a whole stack of papers over there. If I think I speak for the rest of the staff. It's weekends, it's nights. We're usually working every night, even Fridays, even Saturday nights. Okay, that's just what we understand goes with the job. Okay. So if there's nothing else, we'll catch up to you next time.